I posted the recordings of the previous sessions, and I saw that a couple people had watched them. Is it valuable to have the sessions to go back and listen to and watch? I see some people nodding. Okay, that's good. I never know, right? I never know if people go back and look at them or watch them to see kind of specific moments. But you always have access to these. I'll always post the sessions online. The agendas, of course, are also posted. Oh, and that reminds me, I have to post the agenda for today. I don't think I posted that on the link on the agendas list, but I will do that right after class today, or maybe while you guys are in a breakout room. So what do we have on the docket for today? Looks like we're going to take a look at problem set 4, which you guys just turned in, or some of you turned in a couple hours ago. We're going to ponder a little bit with the investigation. I know some of you have already submitted the logistic investigation. And then we'll take a look at big ideas for the, not section 1.5 and 1.6. That's supposed to be 1.8 and 1.9 notes. And then take a look at some of the classwork problems to get us thinking and working on that stuff. And today will be the last new material day. Next Wednesday, we will be doing just review. It'll all be review and headed towards working on exam. And I'll talk a little bit more about the exam here in a couple of minutes. But let's see, what else? I think that's it for kind of overview. So why don't we start with what kind of questions or stumpers or problems did you have for problem set 4? I only got a couple of questions from people, and I seemed to be helpful when I responded. So I assume people were not struggling too much. Or is it that you just wait until the last minute and you feel like you can't contact me? Is that it? No. Well, if that's it, please don't feel that way. You can contact me. Just know that, I may not be like literally waiting by the phone for you to call me to ask me a question, but I will get back to you as soon as I can. Like earlier today, I think Bryce, Bryce, you had asked a question earlier today, and I happened to be like washing dishes. And my hands were all wet, and I'm like, okay, as soon as I'm done washing dishes, I will answer his email. And so it was only like 45 minutes or something, but I wound up answering your email. It took me a long time to do dishes, but hopefully that helped. So don't at all feel like you can't ask a question because it's too late. No, you can ask a question as whenever you need to. So what about problem set 4? What trouble did you run into? Was it difficult? What difficulties did you have? I'm curious.
Did you get a new computer recently?
Did I get a new computer?
Yeah, because I noticed that Maple was looking a lot more HD than it was in the earlier videos.
Yeah, so I'm currently on my Mac right now, and so I have a big iMac with a huge screen and stuff, and so it does a better job, obviously, with the graphics and stuff like that. You'll probably recognize if you look at the screens. Those of you who are Mac users will recognize that they're definitely the 3 buttons, the red, green, and yellow buttons up at the top. So yeah, this is the most recent version of Maple, the one that I have on my other computer. It's technically my work computer, my laptop from my office, and it uses, I think it might be Maple 2018. So it's a couple of versions behind, and so it might look a little weird. And certainly the graphics capabilities on that machine were nowhere near as good as what my desktop here has. So.
It was just so much easier to read
Well,
than the
good. That
previous
makes me
ones. Yeah.
That makes me glad. I was worried. I didn't know whether it was going to be better or worse switching to the new computer. But yeah, it should be better. And I think when I use my document camera, I think the document camera is a little bit clearer on this as well, just in terms of the graphics capabilities.
Mhm.
Questions about problem set 4, difficulties? What was the hardest problem? I'm curious.
Well, like 1A or 1B in specific was just really tedious. It took a while.
Okay. Well, it was the same number of, or the same it's the same distance that you're traveling, but you're doubling the number of steps. So it's a lot of tedious calculations. It's the only time I'm ever going to make you do that. But I want you to experience it so that A, you can appreciate it when Maple gives you an answer like that. But B, also so that you really get a sense that these really are just step after step after step calculations. And one calculation leads to the next. So if you screw up your calculation on line 2, then everything after line 2 is just messed up, right? And that's an issue. But so much of what we do in the real world is automated. And if you can't troubleshoot and figure out where the problem is, that's a problem. That's another problem. Yeah, that's another problem. So yeah, so the other thing that's kind of interesting about that that question, if you take too big of a step, what you wind up doing is you wind up starting in the same initial condition, but you wind up taking too big of a step, and you go, pa-choom, and you shoot, you overshoot, and you wind up exactly on an equilibrium solution. And so the first one, I think you go from up there. What is the initial condition is W of 0 equals 4, and then you take a step of size 1 and you go pow right down to the equilibrium solution of 0, and you just stay there. As opposed to what winds up happening with the other one with a smaller step size is you jump down and then you wind up going back and forth kind of along another equilibrium solution. So if you use too big of a step, you can literally jump right through an equilibrium solution, miss it completely. So that was kind of the point of that problem. That's why I do that one, because it's pretty good. Wow, look at that, upstairs and everything. You're just showing us how tall your house is, Austin. No?
That was the dog. Sorry.
That was the dog. Oh, the dog made me do it. Okay. Other problems or questions, difficulties on problem set 4? How do you guys feel about using Euler's method as a means for approximating? Not bad? It's one of those things where Euler's method is kind of like the gateway drug for numerical solution techniques, right? Once you know how to do Euler's method, then I can say, oh, there's this other method called the, oh God, I always get the name wrong, Runge, I can't remember the name of it, Runge Kapta or something like that. One person is Turkish and the other person is German or something. And they came up with this really cool technique that is sort of like a modified version of Euler's method. And so their numerical method gives better results in a smaller number of steps. But it's really just another numerical method that uses the same technique. You use your differential equation as sort of a map of your slope field. And it says if I start here, it says to go in this direction, take a step, reevaluate, take a step, reevaluate, take a step, reevaluate. And you're just kind of plotting out an approximation for what the solution curve looks like on the slope field. And if you have a really good computer that can do tons and tons of calculations, then you get a pretty good approximation. And by the way, this is what leads us to the ability to create approximations for smooth surfaces. Things in any video game you've ever seen where you see things that they look like they're smooth curves. They're actually not. They're just polynomials that are so the number of faces on the polynomials are so small that to your eye they look like they're smooth curves. So this technique gets used all over the place in kind of modern computing and modern mathematics. We don't get to use it all that much because most of the differential equations that we're going to run into and that we're going to spend our time on, we can either solve them analytically or we can just look at a DE plot and get a sense of what's going on. And both of those are pretty good methods. So that's what's going on there. How about, since nobody else is asking any questions about problem set 4, how about the logistics or the logistic equation model investigation? How's that going? Good. I know some of you have already submitted it. Sorry, some of you already turned it in. About how long did it take you, roughly? Hour? 10 minutes? 10 hours? Or are you just saying I surrender? I don't know if that was you were giving me the French salute there, Wyatt. I didn't know. Oh, I knew you'd appreciate that. The French victory sign, right? We surrender. God, that's a terrible joke.
10 minutes.
What's that? I'm sorry?
It took me about an hour and 10 minutes.
About an hour and 10 minutes. Yeah, my guess is that if you sit down and you work on it, you have to read, right? Obviously, you have to read through what am I asking you to do. But I'm not asking you to do tons of stuff. Just make sure, my advice would be when you're done, when you think you're done, go back and reread it. Go back and reread the assignment, because the number one place where people fall down, go boom on that one is that they like completely disregard one chunk of one of the tasks. Like I'll say, make sure you you make a DE plot and include these initial conditions and make sure that they're all different colors. And people will make a DE plot with all the initial conditions and they're all the same color. Now, it's not a big deal, but I asked you to do it because I want you to prove to me you know how to make things different colors in Maple. So yeah, I'm gonna ding you a point if you don't do that. So duh. So just make sure you go back and reread and that you're answering the questions and doing the tasks that I want you to do there. So that goes, by the way, for even for people who have already submitted. If you want to go back and double check just to make sure, if you need to update the file, that's cool. You can go in there and update it anyways. That's fine. Anybody have any advice for someone who either hasn't started it yet or hasn't finished it yet? My advice would be work faster, I guess. You have T minus 6 hours. So I just want you to be done with it today, right? It's not that big a deal. It is a 50-point assignment, so it's like a homework assignment, but it's not going to take you anywhere near as long as a homework assignment will. It's also getting you a little bit warmed up for the kind of thing that I'm going to ask you to do on the exam, right? So maybe I'll jump ahead and talk a little bit about the exam to make sure that we're all on the same page. The exam's going to have two parts. Part one is going to be, gotta be careful. Part one is going to be you're working with your teammates. So if you're on Team Diff, you're going to be working with Team Diff. If you're on Team Phi, you're going to be working with Team Phi. And so you're going to be working together to solve a series of tasks. Some of them may be problems where you have to come up with a number, a calculation. Some of them may be you have to model the situation. It's not a lot of them. I'm thinking in this right about now, I'm thinking it's going to be like two tasks that you have to tackle. But that's going to be your main task. And you'll get that literally at the end of class on Wednesday. I'll make those available to everybody at the end of class on Wednesday. And as a matter of fact, I'll probably give you the last couple minutes where you can go into a breakout room and start working with your teammates on that. And you will have from end of class on Wednesday through to 5 p.m. on Friday. So you'll have just shy of 2 days to get it done. Right. My expectation is that during that 2 days, you're not necessarily always working directly with each other, but you can kind of separate, work on a task, and then come back together. You can share files, but in the end, you're going to submit a single Maple document to me, right? And I think what I'm going to do is give you a spot where you can post it online. I don't know. I haven't decided whether I want to do email it to me or post it online. Regardless. You'll be turning that in, and that will be the first part of the exam. And right now I'm shooting for like a third to 40%, somewhere in that area of the exam will be you working with your group, right? So that'll be the first part. The second part at 5 p.m. on Friday, I will send out to everybody because you'll be done with your group part, and you can start working on the individual part. And this one will be just you working on specific tasks. And again, it will be 100% in Maple. You'll submit it in Maple. If you want to include things like, I really wanted to do this by hand, you can snap a picture of it and put it in your Maple document. Two things I would ask is, if you're going to do that, make sure that what you put in there is legible, number one. And number two, make sure that it's oriented correctly, which I know is a pain in the butt sometimes. It's an exam, so it needs to be clean and neat and straightforward. So if you do want to include like handwritten work, that's fine. Just make sure that you input it into Maple and it's legible. If I can't read it, I can't grade it. So make sure that you do that. Let's see what else.
Will the teamwork be due at 5 p.m. on Friday, or will
Yeah.
there be a bit of overlap?
Nope, no overlap. The idea being that once you're done working with your team, you're done working with your team. And the individual is just you working on just those problems. And you'll have from 5 p.m. on Friday through to 5 p.m. on Monday. So you'll have the entire weekend plus Monday, all day Monday to finish that up. And you won't have any videos to watch. You won't have any homework to do. That's your work. From Wednesday through to Monday, that's what you'll be working on. And so my plan is next Monday, we'll start in class with a little bit of lecture. I'll actually do some lecture live. Wow, like a real teacher. With chapter 2. We'll start chapter 2 together, and then I'll have more videos for you to watch outside after that. But before Monday, you won't have to worry about watching any videos or anything like that. So that's the game plan. That's the layout. Does that make sense?
Yeah, I have a question.
Sure.
So, so we're only turning in one. It's only one person's turning it in. Like we're only turning one
Yeah, that's
document for all.
the group. Yeah, the group is going to turn in one document. And that's why I think I will have you email me the document and you'll copy the emails of the other people. So whoever turns it in, everybody knows it got turned in and everybody has a copy of what got turned in. There's just no good way to do that, at least that I know of on JetNet. I'm sure there's a way to do it on JetNet. I just don't feel like spending the hour that it's going to take me to figure out how to do that on JetNet. So yeah, it'll be an email submission where you'll send it to me, copy the other people in your group, and everybody will know that it got submitted on time.
Okay. And then the other question was, so you said you could put pictures in Maple. I've done that, but I never figured out how to turn them to like orient them. Do you know how to do that?
So turning them, the short answer is depends on what you're using to make the picture in the first place. If you're using your phone, then whatever it is that, however you're taking the picture, if you're taking it long ways and it's turning out, it's putting them in sideways, then try taking the picture the other direction. Try to reorient your camera. The other possibility would be before you insert the image into Maple, save it to your hard drive, save it to your desktop, open it in some like picture photo editor or whatever, and make sure that it looks correct in the photo editor first. But short of that, it kind of depends on what you're using to make the picture and what your computer is and da-da-da-da. But once it's in Maple, there's no way to rotate the photo that I know of. So, good question.
Okay.
So other than that, are we clear on the game plan for exam? That'll start on Wednesday. And that means between now and Wednesday, you've got to finish up problem set number 5, which is over sections 1.8 and 1.9, which is what we're about to jump into here in a second. But are we all clear on that? Let me get an actual thumbs up from everyone. Verification, you understand. Excellent, excellent, good, good. John, that was very casual. He's like, you're hiding your thumbs up. I like that. Okay, so what we're going to do now is we'll transition into 1.8 and 1.9. Now, those of you who've watched the videos, you know that in 1.8 we learn a totally different analytic strategy for solving differential equations, but only a specific kind of differential equation. So my question to you guys is, what kind of differential equation, what kinds can we solve right now? As of watching 1.8 and 1.9, what are the different types of differential equations that we're actually able to solve?
Linear.
Linear. And so what do you mean by linear?
So it has like a t or an a of t and y term, and then just a b of t term.
Okay, I'm going to share my screen. I'm going to put my document camera up, and so I can jot down some notes. And if you have something you want to add, you can toss that on the screen too. So 1.8 and 1.9 are both really about solving different types of differential equations. And Anthony, or Chris, depending on what he's going by today, says we can solve linear differential equations. And in general, you would describe a linear differential equation as looking like what? Give me an example.
Ty plus 4t.
Okay, so that would be like dy dt, right? So the key here is it's linear if there's some function of t and then times y times our dependent variable plus or minus some other term. And this whole thing right here is really just another function of t. So that's what makes it linear. And for those of you kind of playing the at-home game, this takes its cue from y equals ax plus b. And in the text, they actually use, instead of f and g, they use a of t and b of t. And that's on purpose because it's supposed to play off of what we know as a model linear equation to begin with. Our independent variable here and then our dependent variable on the outside. It's a little messed up because our dependent variable is actually inside the argument of the differential equation. But as long as it fits that bill, right, as long as it's reminiscent of this, then we're okay. And so in the notes, we go through some examples of things that are definitely not. How about this? If I give you an equation that's autonomous, is it a linear differential equation?
Yes.
Somebody said yes. Okay, so what's the definition of autonomous? Just a reminder.
It only has the dependent variable as its
Okay.
argument.
So
or
dy
whatever.
dt on the other side is only a function of y. But notice it doesn't say a function of y only to the first power. So I could give you an example that looks like this. Dy dt equals 2y plus 1. And that's an autonomous differential equation. How about this one? Dy dt equals 2y squared plus 1. Autonomous,
Yes, but not linear.
but not linear. So here's the kicker. If you imagine the Venn diagram, there is overlap between linear and autonomous. But just because something is autonomous is no guarantee of linear. How about the other way around? If something's linear, does that guarantee autonomous? Take a look at our definition of linear.
Could you repeat the question?
Sure, absolutely. If I know that something is a linear differential equation, can I say whether or not it is autonomous? Is it guaranteed to be autonomous? Or guaranteed not to be autonomous for that matter?
It could be either or, couldn't it?
So give me an example of something that is linear but not autonomous. We'll just use dy dt equals
dy dt equals 2t plus 1.
2t plus 1. Is that linear?
Yeah, because it's not it's only to the first degree, right?
Well, keep in mind the thing that's to the first power has got to be y.
Oh,
So that's an example of one that is not autonomous and it's not linear because technically there's no function of y there to the first power, right? It's not y to the first. Yours
okay.
is y to the 0 power. So that doesn't count.
Could you have dy dt equals 2yt plus 1? Would that work, or?
Absolutely. 2yt plus 1. Yeah, that's got a function of t times y. And so that means the right-hand side is not just in terms of the dependent variable. So that is linear, but not autonomous. So a really cool and I think useful device as you're studying this and trying to make sense of this, if I asked you to take about 2 minutes and come up with a Venn diagram that relates linear, autonomous, and homogeneous, Those three words, how do they relate to each other? Is one inside the other? Do they overlap? Does one completely subsume the other? How do they relate with each other? Could you draw me a diagram that does that? It's nothing that Maple's going to help with, obviously, but it's important because it puts these things into relation with each other. As a matter of fact, why don't we do that for starters? I'm going to get you guys into your breakout rooms. Now I have to assign them here manually. And what I want you to do in the meantime, be thinking that question. Relate the words autonomous, linear, and homogeneous. How do they relate to each other if you had to make a diagram? And so while you are thinking about that, I'm going to assign these room listings. Anthony Paul. Okay. The second one. Excellent. Okay, so I'm going to open up the rooms, and what I want you to do is see if you can come to a consensus on one diagram that relates autonomous, linear, and homogeneous, those three terms. Go to it. Shoo. Run along, John, run along. Okay, and while they're doing that, I'm going to hit pause. Okay, so I'm continuing the recording now because what I want you to do is I'm going to have each group share their diagram. And this is an active thing because if you're not in their group, your job is to try to come up with a counter example that proves their diagram can't be correct. Everybody clear on that? So you're going to try to figure out a counterexample that kind of disproves their diagram. Does that make sense? So this is what I like to call being a critical friend, right? We're not doing it because we want to be jerks to each other. We're doing it because we're trying to kind of test and poke around the boundaries and make sure that everything that we're saying really is correct. And you need people to be at least a little bit critical of what you're saying. It doesn't mean critical like yeah yeah yeah. It's critical like taking a critical eye towards what you're saying and being willing to give you feedback and kind of point out places where it might not be correct. So let's be critical friends, shall we? And who wants to go first? What group wants to go first, taking a look at the diagram that they came up with?
I can go.
Fire away. You want to show us your diagram?
Yes, 1 sec. Okay, so this is just what we thought of because if
Can
something.
you guys see that okay in terms of showing up okay?
Because if a function is homogeneous, it has to be linear, so it kind of like envelops all of it.
Okay.
But a function could be either linear or autonomous and not be the other, but a function can also be linear and autonomous.
Okay.
So it's kind of showing that it can be one or the other or both at the same time.
So, okay, well, that makes sense. Okay, so who wants to go next? We'll take a look at theirs. Remember, if you're not in their group, your job is to come up with a counterexample for it. So next group.
We can go.
Okay, I was
Were we
just about to
supposed to come up
volunteer
with
somebody.
equational examples?
Not
for each
necessarily.
one?
I just want a diagram. I just want a
Oh.
diagram.
Well, then we have a diagram.
You have a diagram and equations, or?
Yeah, we did.
Hey, look at that.
No, right? We're pretty progressive. So
Awesome.
we have So for linear and autonomous, right?
Okay.
Autonomous doesn't have the, what is it? The one on the bottom. That's dependent. Is that right? The dependent variable, the independent variable. It does not have the independent variable. So we wrote an equation that was linear, and it does not have the independent variable.
Okay.
Okay. And then for our crossover between homogeneous and linear, homogeneous is just a linear function, but without the second B function, right?
Homogeneous.
Homogeneous, or homogy, as we affectionately call it that because we abbreviated it. So I might
That's
as well read it.
fine by me.
So we just stole the example from the book, or the notes.
Okay.
That was that crossover. And then between the homogy and the autonomous, we just got rid of the +1 at the end. Does that work? I figured we thought that worked. We thought we were pretty clever. And then in the middle here, since this is already a linear function, we just kind of copied and pasted that one in the middle to encompass all three. And yeah, that was our grand scheme.
So you have dy dx equals 2y in two different places. Right?
What's that?
So the last two that you uncovered, aren't they the same thing?
They are, yes.
And so it can be both homogeneous and not linear, and homogeneous and linear.
Yeah, I guess so. I guess you could do this thing right here that I'm about to do. Just kind of.
Ooh.
Oh no, look at that.
Sneaky.
Yeah.
Sneaky. Okay, so do I assume then that the blue line continues and follows the teardrop shape or something?
I guess so. It just
Okay.
kind of encompasses only this bit, but these two are pretty much the same thing. Well,
Okay.
they are the same thing. So
Okay. So your diagram would suggest then that it's possible to be autonomous but not be homogeneous.
sorry, what was that?
So your diagram seems to suggest that you can be autonomous but not homogeneous.
Yes.
And it also suggests you can be autonomous but not linear.
It does seem to suggest that, yeah.
Okay. So I'll let
These
you
are the
ponder
two.
that for a second.
Go
So
ahead.
third group, let's take a look at your diagram, see what you got. Oh, interesting. Okay, what do we got?
So we kind of figured that the homogeneous has to be linear, so it's
Okay.
completely encompassed by linear. And we also figured that a function can be homogeneous, linear, and autonomous. So that's why it's overlapping. And a function can be linear and homogeneous, but not autonomous.
Okay.
And they can be autonomous, but neither
Okay.
linear and homogeneous.
It really does take a lot of work to train yourself to not say homogeneous, doesn't it?
It does.
It's hard work. I blame the milk industry. It really is. But if you look it up, Google the word homogeneous, the way it's spelled, the way it sounds, and you'll find, oh, you meant homogeneous. Because yeah, it's got some bad associations with some bad biology that you don't want to be associated with that word. So so yours suggests that it's possible to be homogeneous but not autonomous.
Yes.
Can you give me an example of what that might look like? dy dt equals
dy dt can equal y times t.
y times t. In that case, it's definitely linear because it's y to the first power times a function of t.
Mm-hmm.
Definitely linear. It's definitely homogeneous because it's only one term, right?
Mm-hmm.
And technically, we could say it's separable as well
Yep.
because you could just divide the y to the other side, use the separation of variables technique. but it's definitely not autonomous because the right-hand side is not a function of just y. Okay. So can you come up with, anybody from the other two groups, can you come up with a counter example for this diagram? Something that would make it blow it out of the water. Doesn't work. Because I think this might have been the modification or part of the modification that you were getting towards on your diagram, Stephen. You were starting to like remove the boundary on one thing, and what you'd probably wind up finding is you'd have to subsume one of the circles into another.
Isn't it possible to have an autonomous equation that isn't linear?
Good question. Is it possible to have an autonomous differential equation that is not linear? Can somebody think of an example?
If we had dy dt equals y squared.
Bing, bing. That is autonomous, and it is not linear. So where would that go in this diagram?
That would go over. Oh, okay. I messed that up. Never mind.
It's okay. It's okay. This is why these diagrams are a pain in the butt to come up with. But once you've got them, it's really helpful. Yeah, and so you guys can do this. I mean, you've got your you have the ability to do annotations, right? So pull up your annotation, and I'm going to say a differential equation. I'm going to say it, and your job is to put a mark where you think that differential equation would go. And so for starters, I'm going to erase the one that somebody just made. Oh, I can't erase that. Can I unstamp it? I don't think I can unstamp it. I don't know. Yeah, there we go. So for starters, what I want you to do is I want you to use a stamp that is a check mark. So for this one, you're going to use a stamp that's a check mark. Here's the differential equation. Listen carefully. dy dt, they're all going to be dy dt. dy dt equals sine of y. dy dt equals sine of y. Check mark, I said. Ooh. So where you put that last check mark, whoever put the check mark inside the circle of linear, is dy dt equals sine of t, or excuse me, sine of y. That can't be linear because it's the y is inside the sine function. So it's not just y to the first power. So I agree with you all, except that last one. It needs to be in the autonomous, but neither of the other two category. So good. Excellent work on that one. Okay, so I'm going to clear those. Okay, so here's the next one. dy dt equals, wait for it, y t squared plus 3t. dy dt equals y t squared plus 3t. Oh, you're clumping. Okay, so what makes it linear? Who wants to take a stab at that?
The y to the first power.
Y to the first power, and there's a multiplier for that. It's a function of t, and then the other term is a function of t. So it's linear. What makes it non-homogeneous? How come we can't put it in the homogeneous circle?
Is it because there's two parts to it? Because it's y plus t squared. If it was just one part, then it'd be homogeneous.
Yep. There's two functions of t. One of them's multiplying y, the other one's just hanging out by itself. And as soon as you have that second part, that second function of t sitting there by itself, it's no longer homogeneous. Right. So up to section 1.8, we had no trouble solving linear homogeneous differential equations. What's the method for solving that we know to solve linear homogeneous differential equations? I'll give you a hint. We learned it way back in 1.2. It rhymes with reparation of variables. Hey, there we go. Yeah. So it turns out that we know how to solve anything that is in this region in here. Anything that's in this region in here, we know how to solve. And by the way, that includes autonomous differential equations that happen to be also homogeneous and linear. Anything that's in the homogeneous camp, we got. Doesn't mean that they're easy integrals, right? The integration can be a pain in the butt, but we know a method that works. 1.8 and 1.9 teach us methods for solving anything that's in this camp right here. Anything that's in there, we know how to solve. But notice, there's still a whole lot here that we don't know how to solve. There's a whole lot in this region down here that we don't know how to solve. And there's a whole bunch of stuff outside here. See if I can draw. Anything that's out in here, there be dragons. We just have no idea what to do with it. If it's not linear and it's not autonomous, we're dead in the water, right? And by the way, that's an awful lot of equations. I would say it's approximately, carry the two, infinity number of type of equations, right? This is like when you're in a baby algebra class and you learn how to solve a linear equation and you're like, I'm the king of the world. And then somebody shows up with a quadratic and you're like, what the fuck is that? Never seen anything like that, right? Then they blow your mind and show you a way to solve that one. Same thing in differential equations land. We're going to learn how to solve certain types. But the methods for this type don't necessarily apply elsewhere. And we're not going to get too terribly more complicated than linear differential equations in this class. Not because they're not useful or important, but because every single method that's out there, it would take us a long time to learn. Sometimes it's just easier to really focus on one type, learn some methods, develop some muscles for being able to solve differential equations, and then go from there. So nice job. This diagram, I think, fits the bill perfectly. And hopefully you can see why. What's the overlap? And when do things overlap? There are autonomous differential equations that are not linear. Standard dy dt equals y squared, not linear, but solvable. We can solve that. It's not impossible for us to solve. There's an awful lot of equations that are not autonomous, or excuse me, that are autonomous and not solvable by us. Let me give you an example, and I'll do this by kind of taking control. Take control of your screen. So I'm going to have you relinquish control here. There we go. Let me see if I can find a new Maple document, or I'll just throw it on the bottom of these notes here. Go up to the top of the screen here. Okay, I'm going to share my screen. I want to show you an example of something that on the surface doesn't look like it would be terribly complicated. So what if we wanted to desolve Maple? Come on, let's do this. Let's desolve a differential equation, something like it's going to be y of t versus t. And let's make it something like y of t squared plus 2 times y of t plus 1. Doesn't look like it's that complicated. It's definitely autonomous. The right-hand side is only in terms of y of t, so we have a sense that its slope field is going to have kind of equilibrium solutions horizontally. But what would the solution look like if we wanted to solve this? Come up with an analytic solution. What does the solution equation look like? You're like, That's not so bad. What if I change this now to 2 times the natural log of, not capital L, the natural log of y of t? It's still an autonomous differential equation. But you can tell Maple had to think about it for a second. And that solution is a little bit ugly because there's still an integral in the solution. In other words, Maple's like, look, I don't know how to solve this unless you give me a little bit more information. This thing actually is dependent upon an integral for a solution. It's messy, it's yucky. Ugh. And so you can have an autonomous differential equation that seems like it should make sense, but yet it does not have a solution that's easy to find. Or in this case, I don't think it's actually solvable analytically so that you could write it as y of t equals some junk. It's just not solvable. So we have to kind of, if we're thinking about our classification schema, recognizing if it's linear, we have a method for it. If it's autonomous, we understand what that means, but it doesn't guarantee that, unless it's linear, that we have a particular method for solving that, right? So being willing to kind of classify a differential equation that you run into and say, oh, that one we can tackle, that one we can't. Okay, so what I want you to do now, we're going to split up one more time in breakouts. I'm just going to name these things here before I forget. We're going to split up into breakouts, and you guys are going to be looking at the 1.8 and 1.9 classwork. So hopefully you saw there are 2 problems that are assigned, one from 1.8, one from 1.9, and the 1.8 problem is all the same. So all the groups have the same 1.8 problem. That's because I want you to practice a little bit. You're going to have to use Maple on that one. So let me go ahead and open up the rooms again. And I don't know, maybe give you like 15 minutes or so, give you a chance to work out the solution for this. We come back together, we'll talk about that. And then I'd like to spend a little bit more time looking at some of the more advanced problems, especially in 1.9 as well. So go to it.